Okay, good morning. Welcome to
FamilyMath475a.
FamilyMath475. So I asked what you wanted to learn about today, and you said different bases, and specifically what base?
Hexadecimal.
Hexadecimal. Okay. We're going to do probably over the first couple of movies a quick review of bases in general, and then then talk about hexadecimal, which is kind of fun. So let's talk about what does the base even mean? So if I have a number and our marker is dying, we better order markers after this. So if I have the usual number like 3,784, and this is in base 10, a normal number that we see, what does the base mean?
So it means that you're counting by powers of 10. You have 4 times 10 to the 0, plus 8 times 10 to the 1, plus 7 times 10 squared, plus 3 times 10 cubed.
Okay.
And you're in base 10.
Yeah, and that would be base 10. Why? Can you tell me why 10 to the 0 equals 1? Do you know?
Because when you go from 10 to the 5th to, let's say 10 to the 5th and to 10 to the 4th, you divide by 10. 10 to the 1 is 10, so it's 10 divided by 10, which is 1.
Yeah, that's a great way to think about it. Okay, good job. So if we want to talk about base 2, which in the past we have done, and we've used stamp cubes to talk about. So give me a number. Can you give me a 4-digit number in base 2?
1011.
All right. And what does this number mean? Why don't you say?
So it means that you have 1 times 2 to the 0.
Okay, and which is what?
1.
That's 1. That's a number we would normally call 1. 1 times 2 to the 0.
Then plus 1 times 2 to the 1, which is 2.
2, so this is the 2's digit.
Plus 0 times 2 squared.
This is the
4's
digit.
Plus 1 times 2 cubed.
So it's the 8's digit.
All right, so our digits are powers of 2. 1, 2, 4, 8. And what would we normally call this number that is 1, 0, 1, 1 base 2?
It's 11.
This is the number we would normally call 11.
In base 10.
Yeah.
Base 10. Okay. And base 2 has a kind of a fun way of looking at it with snap cubes, where we can pretend these are the 1s
1.
and these are the 0s.
So we can create a number. We can start number 11, which is this number.
All right, so here's our number 1, 0, 1, 1.
And then we can add numbers to this.
Yeah, so what's another 4-digit number?
So let's say 1, 0, 1, 0.
Okay.
This would be 11 plus 10 should equal 21.
Right, we're hoping we find 21 here.
So,
And when we add, what happens?
well, 1 plus 0 is 1.
And we'd have a 2. We have 2 here.
Yeah, because 1 plus 1 is 2.
Since we can't have 2's in base 2. So it leaves, well, goes to a 0 and then a 1 over here.
Okay.
Then the same thing occurs. Can't have a 2. It's a 0.
Whoa, you skipped this one completely.
Oh.
So you said 1 plus 1 is 2, which becomes a 1, 0. Now you're on this digit.
0 plus 0 is 0.
Okay. So what happens to
You have
this?
the 1.
Nothing. It
Alright.
just stays like that. And then here, again, you have a 1.
So this is 1, 0, 1, 0, 1.
All right, and what are our digits here?
1, 2, 4, 8, and 16.
So 16 plus 4, which is 20, plus 1 is 21.
Okay, 21. All right, good job.
Cool.
Good job. All right, let's talk about something else related to different bases.
Alright.